Lesson 4, efficiently adding integers and other rational numbers. Students understand the rules for adding rational numbers. Add rational numbers with the same sign by adding the absolute values and using the common sign. Add rational numbers with opposite signs is subtracting the smaller absolute value from the larger absolute value and using the sign of the larger absolute value. Students justify the rules using arrows and a number line or by using the integer game. They extend their findings to begin to include sums of rational numbers. Represent the sum of 3 plus 5 on the number line. So I go to 3 plus 5, 1, 2, 3, 4, 5. So the answer is 8. How long is the arrow that represents 3? 3 units. What direction? To the right. How long is the arrow that represents 5? Oops. It's 5 units. What direction? To the right. What is the sum? It's 8. If you were to represent the sum using an arrow, how long would it be and what direction? The arrow represents the sum is 8 units long, pointing to the right. What is the relationship between the arrow representing the number on the number line and the absolute value of the number? The length of the arrow representing a number is equal to the absolute value of the number. Do you think that adding two positive numbers will always give you a graded positive number, and why? Yes, because the absolute values are positive, so the sum will be a greater positive. On a number line, adding them would move you further away from 0 to the right or above on a number line. Represent the sum of -3 plus -5 on the number line. So -3 and -5. How long is the arrow that represents -3? It's 3 units. What direction? It goes to the left. How long is the arrow that represents -5? 5 units, and it goes to the left. What is the sum? -8. If you were to represent the sum using an arrow, how long would the arrow be and what direction? It'd be 8 units to the left. Do you think that adding two negatives will always give you a smaller negative number? Why? Yes, because the absolute values of negative numbers are positive, so the sum will be a greater positive. However, the opposite of a greater positive is a smaller negative. Very important. What do both examples have in common? The length of the arrow representing the sum of the two numbers will be the same. The same sign is the same as the sum of the absolute values of both numbers. Add integers with the same sign by adding absolute values and using the common sign. Very important. Decide whether the sum will be positive or negative. Find the following sums. Decide whether the sum will be positive or negative without calculating the sum. So the first one will be negative, the second one positive. 2 negatives is a negative, 2 negatives is a negative. These are all positive, so it'll be positive. Negative, so they'll be negative. The other side wants us to actually find the sums. So 15 plus 7 is 22. -4 plus -16 is -20. -18 plus -64 is -82. And -205 plus -123 is -328. The rules for adding opposite sign. Represent the 5 plus -3 using arrows on a number line. How long would the arrow that represents 5? It'd be 5 units to the right. How long is the arrow that represents -3? It'd be 3 units to the left. Which arrow is longer? 5 units to the right. What is the sum if you were to represent the sum using an arrow? How long would it be? And in what direction? So 5 plus -3 is 2. The arrow would be 2 units long and point up or right. represent 4 plus negative 7 using arrows on a number line. In the example above, what is the relationship between the length of the arrow representing the sum and the length of the arrow representing the two additives? So I got to go from 0 to 4, then back 7. So the length of the arrow representing the sum is equal to the difference of the absolute value lengths of both arrows representing the two additives. What is the relationship between the direction of the arrow representing the sum and the arrow representing the two addends? The direction of the arrow representing the sum has the same direction as the arrow of the addend with the greater absolute value. So what that means is my arrow is negative 3, or 3 to the left, because when I went back, that was more. Write a rule that will give the length and the direction of the arrow representing the sum of the two values that have opposite signs. The length of the arrow of the sum is the difference of the absolute values of the two addends. The direction of the arrow of the sum is the same as the direction of the longer arrow. Circle the integer with a greater absolute value. Decide whether the sum will be positive or negative without actually calculating it. So this would be a greater absolute value, greater absolute value, greater absolute value. So positive, negative, negative. Find the sum. So 10 minus 7 is 3, and it's going to be negative 3. 65 minus 12 is 53, and it's going to be positive. 16 minus 8 is 8, and it's going to be negative because that's negative. 126 minus 105 is going to be 21, negative 21, because that's negative. Applying integer addition rules for rational numbers. Find the sum of 6 plus 2 1/4. The addition of rational numbers follows the same rules for the addition of integers. Find the absolute value of the numbers. So the absolute value of 6 is 6, and the absolute value of 2 1/4 is negative 2 1/4 is 2 1/4. Subtract the absolute value. So 6 minus 2 1/4. So 6 minus 2 is 4. 4 minus 1/4 is 3 3/4. The answer will take the sign of the number that has the greater absolute value. Since 6 has the greater absolute value, arrow length, my answer will be positive 3/4. Solve the following problem. Show your work. Find the sum of negative 18 plus 7. So found the absolute values. I subtracted them, got 11. And because negative 18 is larger, it's going to be negative 11. If the temperature outside was 73 degrees at 5 p.m., but it fell 19 degrees by 10 p.m., what is the temperature at 10 p.m.? Write an equation and solve. So we have 73 plus negative 19. I found the absolute values, subtracted them, got 54, and it's going to be a positive 54 because 73 is bigger. Write an addition sentence finding the sum using the diagram below. So I start at 0, go back 10, and then up 3 1/2. So negative 10 plus 3 1/2, find the absolute values. I'm going to subtract them. So 10 minus 3 is 7, but then 7 minus the other half is 6 1/2. So it's going to be negative 6 1/2.